Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to look at our third and final method of solving systems of equations. And today's method is called elimination. So we've already done graphing, we've already done substitution, and now we are focused on this new method called the elimination method. And after you've learned all three methods, it'll be up to you to decide which one works the best for each system. Sometimes graphing will be easiest, sometimes substitution will be easiest, sometimes elimination will be easiest. So let's just hop right in. I think we're going to have 4 examples to do today. And again, they'll get progressively harder. So let's look at the example on the left. Now, if you remember our goal, right now both of our equations have 2 variables. But we can't solve an equation with 2 variables. We have to eliminate one of them or get rid of one of them, and then we'll be able to solve the equation, right? Because 1 variable, no problem, easy to solve. 2 variables, can't do it if we're just working with 1 equation. So you'll notice here that none of these equations are solved for a variable, right? And if I was trying to do substitution, I would have to get one of the variables by itself. So let me just give you a quick review of what I'm talking about. Let's take the first equation. I would have to use different inverse operations, right? I might have to add 4x to both sides. Oops. So then I get negative 5y is equal to 4x plus 5. Then I got to divide everything by negative 5. And that's going to give me y is equal to negative 4/5 x minus 1. And then I'd have to take this quantity right here and substitute it in for y in my second equation. And then go ahead and solve for x. The problem is, right, I'm going to have to work with fractions. I've got to do all this work beforehand to get the y by itself. And then I have to use substitution. So substitution actually wouldn't be very efficient in this case. Fortunately, we have another method that is efficient here, and it's a way that we can easily eliminate one of the variables right away, rather than having to do all this substitution. And what I mean by that is we're either going to add or subtract the equations together. You'll notice here that in these 2 equations, we have a negative 4x in the first and a positive 4x in the second. Well, if I add these equations together, if I add the second one to the first one, negative 4x plus 4x is 0x. Negative 5y plus 10y is 5y. And 5 plus negative 10 is negative 5. Well, we have just eliminated one of the variables, right? Because 0x is 0. So I really just have 5y is equal to negative 5. And very easy equation to solve here, right? Just divide by 5. And I get y is equal to negative 1. So look how quickly we solved for one of the variables here, right? We didn't have to do any substitution, work with fractions, etc. We just had to add the equations together, and one of the variables disappeared or was eliminated. Now, of course, we have our choice. We can take this y is equal to negative 1. We can go back to the first equation, or we can go to the second equation to figure out what x is. I'll just use the first one. So I have negative 4x minus 5y is equal to 5. Sorry, minus 5y, not 5x. I know that y is negative 1, so I get negative 4x minus 5 times negative 1 is equal to 5. That gives me negative 4x plus 5 is equal to 5. Subtract 5 from both sides. I get negative 4x is equal to 0. And if I divide by negative 4, I get x is equal to 0. So x is equal to 0, y is equal to negative 1. That is the solution to this system of equations. Pretty easy, pretty straightforward. Again, if you had tried to solve this using substitution, it would have taken you a lot longer and you would have been more prone to make a mistake. Let's move on to another example. We'll again work with the one on the left over here. So remember, I said you can add or subtract the equations together. Well, if I'm looking at the one on the left, I notice that the y's both have the same coefficient. They both have 6 as a coefficient. So it seems like we should be able to eliminate those. However, if I add these equations together, right, let's just think about what I would get. X plus 10x is 11x, 6y plus 6y gives me 12y, and negative 19 minus 28 gives me negative 47. Well, let's not forget the y. Well, this really hasn't helped because now I'm still left with 2 variables, and I need just 1 variable for me to solve. So adding the equations didn't work. But had I subtracted instead, the equations, well, I would get x minus 10x, so that would give me negative 9x. It's important that you are subtracting each of these quantities. So you're really distributing that negative sign and then adding the equations. So if you want to, right, that's what you could do. You could just distribute the negative, so I get negative 10x minus 6y and plus 28, and then you could go ahead and add everything. So x plus negative 10x is negative 9x, 6y plus negative 6y is 0y, and negative 19 plus 28 gives me positive 9. Well, we have now come up with a single variable equation because the y's were eliminated. And now I just have to divide both sides by negative 9 to get x is equal to negative 1. So not only can you add 2 equations together to get rid of or eliminate one of the variables, you can subtract them as well. And it just depends as, well, do those coefficients that are the same, right? In this case, it was our 6's. Right, these 6's had the same sign. So if I added them together, I wasn't going to get 0. I was going to get 12. But if I subtracted, that would give me 0 y's. Don't forget your last step. Got to take this x is equal to negative 1, substitute it back into one of these equations. Again, I'll just go with the first one, but you could do either one. I know that x is equal to negative 1. So let's add 1 to both sides. That'll give me 6y is equal to negative 18. Divide by 6. And we will get y is equal to negative 3. So x is equal to negative 1, y is equal to negative 3. Remember that you can write that as a ordered pair if you'd like. Negative 1 comma negative 3. That's another way of showing what your answer is. Okay, so we've now covered examples where you can add or subtract to eliminate one of the variables. Now we're going to look at a system of equations where you have to do something before you add or subtract. So let's move on to the next page, I believe. Yes, right here. And again, we will focus on the example on the left. So you'll notice, and actually take 30 seconds to think about what is different about this system of equations from the last two, or what may make this more difficult than the last two. Well, none of the coefficients for the x's or y's are the same, right? So I have negative 4x and positive 2x. Well, if I add those together, I'm not going to get 0. If I subtract those together, I'm not going to get 0. And then I have negative 4 and 8 for the y's. Same thing. If I add those together, I'm not going to get 0. If I subtract those, I'm also not going to get 0. So we have to think, is there something else I can do before I add or subtract? Well, what if I multiplied one of the equations by a constant? So let's say, what if I multiply this first equation by 2? Let's see what I get. I would have to distribute to every single term. So I get negative 8x minus 8y is equal to 16. And again, I haven't changed the equation at all. I've kept it balanced because I did the same thing to both sides. I multiplied the left side by 2 and I multiplied the right side by 2. But now look at what happens, right? Now let me bring down my other equation. So 2x plus 8y is equal to 8. Now, and again, that just came from our second equation. So now I do have two variables that have the same coefficient or opposite coefficients, namely the y's, right? So for one y, it's negative 8. For the other y, it's positive 8. So think about, should I add or subtract those together? Well, if I add both equations together, negative 8x plus 2x gives me negative 6x. Negative 8y plus 8y gives me 0y. 16 plus 8 gives me 24. So whenever we write this, I get negative 6x is equal to 24 because the y's have been eliminated. Then I can solve by dividing both sides by negative 6. So I get x is equal to negative 4. And then again, same process. Take this value. Let's substitute into the second equation this time. 2x plus 8y is equal to 8. I know that x is equal to negative 4. Negative 8 plus 8y is equal to 8. Whoops. Add 8 to both sides. So 8y is equal to 16. And divide both sides by 8 to get y is equal to 2. So the only difference here is that before I added or subtracted my equations together, I had to pick a number to multiply one of the equations by. And you're choosing your number based on, well, what will give you the same coefficients for one variable? You may think, well, Mr. Foss said there was a different answer here. I didn't have to multiply the first equation by 2. And I would say, you're right, there were other options. So let me get rid of this work and just show you what another option could have been. So instead of multiplying the first equation by 2, we could have also just multiplied the second equation by 2. And if I do that, I get 4x plus 16y is equal to 16. Bring down the first equation. So I get negative 4x minus 4y is equal to 8. And then you'll notice if I add these two equations together, the x's will eliminate. Right? 4x plus negative 4x is equal to 0. So I would get 16y minus 4y is equal to 12y. 16 plus 8 is equal to 24. And then I would divide both sides by 12. And I would still get y is equal to 2. So different choices here. You just need to make sure that when you multiply one of the equations by a number, you're going to have the same or opposite coefficients in front of one of the variables, right? Like positive 4 and negative 4, or negative 8 and negative 8, or negative 8 and positive 8. That way, you can then either add or subtract them together to eliminate that variable. Let's do one more example, which will be the hardest one that you might see for elimination. And then we'll be done. So as always, take 30 seconds to think, what's different about this example on the left from all the ones we've done so far? Well, you'll notice that not only do they not have coefficients that are the same or opposites right away, but if I multiply one of the equations by another, right, there's no way for me to get the same or opposite coefficients. Let's just look at the first equation. right? If I multiply the first equation by 2, I'm going to get negative 6x, which is not, positive or negative 5x. And there's nothing I can multiply the y's by to make them become the same or opposite to the 4y in our second equation. So there's no good number to multiply either equation by so that I can eliminate one of the variables. And when this happens, you're going to have to multiply both equations by a number. So both of these are going to have to be multiplied. And essentially, you want to pick one of the variables. In this case, I'll just pick x. I need to figure out, okay, what's the least common multiple of 3 and 5? Or just what is a common multiple of 3 and 5? Well, 15, right? So I could multiply the first equation by 5 and the second equation by 3. My two new equations will become negative 15. Oops. I'm going to get negative 15x minus 25y plus 20. Sorry, equals 20, not plus 20. And then when I multiply the second equation, I'm going to get positive 15x plus 12y is equal to 6. Now I just need to decide, do I need to add or subtract these equations together? Well, I just need to add, because negative 15 and positive 15 are opposites, so those will automatically eliminate. And I'll get negative 25 plus 12, which is negative 13y, is equal to 26. And we'll divide by negative 13 to find that y is equal to negative 2. Again, once we multiply both equations by a constant, everything else was the same as what we've been doing. I'll pick the first equation to figure out x. So negative 3x minus 5y is equal to 4. I know that y is equal to negative 2. So I just do some simplifying here. So I get negative 3x is equal to negative 6. Divide both sides by negative 3. And I get x is equal to positive 2. So x is equal to positive 2, y is equal to negative 2. So you may have to multiply both equations by a constant. The easiest way to figure out what those constants should be is just to think about, well, what's a common multiple of two numbers, right? And you can either look for the common multiple of 3 and 5, or you could look at the common multiple of 4 and 5. Right? It's possible that maybe you wanted to multiply the first equation by, let's get rid of this just so I can show you another way. If I look for the common multiple of 5 and 4, well, that's 20. So I'd multiply the first equation by 4 and the second equation by 5. And I think you'll notice a pattern here, right? To find a common multiple, if I'm using these two numbers here, right, 5 and 4, well, you multiply the first equation by what the other coefficient is, 4, and you multiply the second equation by what the first coefficient is, 5, or negative 5. Both would work. And then when you come up with your two new equations, I get negative 12x minus 20y is equal to 16, and 25x plus 20y is equal to 10. And you'll notice that when you add these together, the y's will eliminate. So again, multiple ways to approach the same problem. As long as your math is correct, you will get the same answer either way. All right, I will leave it here. I think you've got plenty of examples to help you work through the rest of the problems. As always, enjoy the rest of your day, and we will look forward to seeing you next time.